In this video, we'll talk about bases that are larger than 10 and how those work. So primarily, we're just going to be looking at base 12 and base 16. So let's start with base 12. Now, when we count in a base smaller than 10, like we were talking about base 7 in the last video, so if I was counting in base 7, I would start with 0, 1, 2, 3, 4, 5, 6, but we don't have a 7 in base 7, so once you get to 6, that's your last digit. So then you're going to have a 0 in the 1's place and a 1 in the 7's place. So this is 1, 0, base 7, but that's 7 in base 10. And then the next number would be 1, 1. You have 1 in the 7's place and 1 in the 1's place. And, oops, it's not base 8. So that's base 7, but that's equal to 8 in base 10. And so on. So you would continue on that way. Now here's the problem with the base being larger than 10. So now we'll count in base 12, and I'll count 0, 1, 2, and you get the idea of that. 8, 9, but that's not my last digit. Because we're in base 12, I need a digit for 10 and I need a digit for 11. But the problem is that we don't have one single symbol to use, and we need the symbol to be in the 1's place because we don't have 12 if we're only at 10 or 11. We can't move over to the next place value. So what we're going to do is we're going to use letters of the alphabet. So A in base 12 is equal to 10 in base 10. And then, sorry, in base 12 we're going to have an 11 as well. So B in base 12 is 11 in base 10. And now we're on to the next place value because now we're up to 12, which is our base number. So then we would write 1, 0. And 1, 0 in base 12 is just 12 in base 10. So notice that whenever we write 1, 0 in whatever base, we're talking about that base. We did that over here with base 7 as well. When I have 1, 0, base 7, that's 7 in base 10. So if I write 1, 0, 157, then that's just equal to 157 in base 10. All right, so we have these two extra symbols in base 12, and that's what we're going to work with here. So let me take out some of this. We have room to work. So let's take a look at a base 12 place value chart. And I always make my place value chart for whatever the weird base is. So the base that's not base 10. So we have the 1's place, the 12's place, then I need 12 squared, which is 144, and then I need 12 to the 3rd power, which is 1,728. So it's 12 to the 0, 12 to the 1, 12 squared, 12 to the 3. And I, of course, could keep going. I'm just going to stop here because that's already pretty big. And suppose I have a base 12 number, 2003, because I'm going to take it easy on myself on what we have to do here. All right. Let's make a little more room. Okay, so what is 2003 in base 12 equal to in base 10? So it's 2 times 1,728 plus 3 times 1, which is just 3. So let's see, this is going to be 3,459 in base 10. So that's my final answer as to what 2003 base 12 is equal to in base 10. Now, let's take another base 12 number, and I'm just going to make a smaller chart here. I'm just going to go 144, 12, 1. And suppose I have A to B. Then how would I convert this to base 10? Well, I know that A is equal to 10, so I'll take 10 times 144 plus 2 times the 12, because we have 2 in the 12's place. And then B is 11, so it's 11 times 1, which is just 11. So let's see, this is 1440 plus 24 plus 11, and that makes 1,475, right? Yes. 1,475 in base 10. And I keep writing that base 10 in there just to be really explicit about what base I'm in, but you wouldn't need to write that. So if you just wrote 1,475, that would be fine. So far we've done 3 examples where we're converting from the base, whatever it is, base 7 or base 12, and we're converting to base 10. So how would you work that backwards? Let's take a look. So we're still working in base 12. Oops. All right. And suppose I have the number 247. And I want to know, what is this equal to in base 12? All right, so I'm going to make a base 12 chart. 1's place, 12's place, 144's place. And I don't go to the next place value because that's 1,728. So you may have to check because you're not going to have all these memorized off the top of your head. But we just used it, so I know 1,728 is larger than 247, so we're not going to have any groups of 1,728 because we don't have a big enough number for that. So I'll start by dividing 144 into the 247 because I want to see how many groups of 144 we have. So I can't do this. I can't write 247. It happened to work out that we have the same number of digits in that we're starting with as we are going to have that we end up with. But 247 is in base 10. It's not in base 12, so I can't just pop it right into the chart. So I'll divide 144 into 247. It goes once. And I'm having to do this old style. So we get 103 because I need a remainder. Now you can enter this into the calculator and you'll get 1 point something, some kind of decimal. Looks like a mess. So what you do when you get that is subtract 1, because I just subtract whatever that whole part of it is. I just want the decimal. So I subtract 1 in this case. If it was 7 point whatever, I would subtract 7. And now I have just 0 point some decimal. Now I'm going to multiply that by, what did I just divide by? 144. So I'll take that result times 144, and that'll give me 103, which is the remainder. So I'll take the 1, it's one group of 144, so that's what goes in the 144's place. And now we have 103, but I can spread that out amongst the rest of the place values. So I look at the next place value, and it's 12. So I'll do the same procedure again. 12 into 103 goes how many times? How many times would that be? Let's see. 8. Let's try 8 and get this other number out of the way. All right, so 8, yeah, that looks good. That would be 96, and I subtract and I get 7. So it's 8 remainder 7. So that means we have 8 groups of 12. That puts 8 in the 12's place, and the 7 goes in the 1's place because it's the last thing left. So once you get down to that very last remainder, and it's just the 1's place, 1 goes into 7 times. You don't have to write out that division. So, what's my final answer? 247 in base 10 is equal to 1 187 in base 12. And I would read it that way, 187. I just read in each individual digit because it's not 187 because that implies base 10. All right, so I'll save this and then we'll go to part 3 where we do some computation.